All right, so I'm going to be looking at solo attempt number 1 here and seeing if we can maybe get some really deep statistical analysis going on. And so what I've started by doing is I've looked at these two plants to try to see if I can figure out the smallest number I need for a dot plot and the biggest number I need for a dot plot. Because remember our elements of statistical analysis, we can create some dot plots to see what the data looks like. We can then we can calculate the mean absolute deviation and the mean to kind of figure out where the center is and the spread of it. Remember, the dot plots help us think about the shape. And then we can actually write about those things to answer the question. So let's see here. Let's go ahead and start this. So I know the smallest point I need to see is 20. The biggest one I need to see is 50. And that's out of all of these. Oh, actually, maximum, I got that wrong. Should be 51. So I'll have to go a little bit further past that. So I think I'll start both of my scales at 20. And I'll have them go up to 60. And I might have them go by fives. So that would make the middle one would need to be, let's see, 25, 30, 35, 40, 45, 50, 55, 60. So I was pretty lucky there that I just spaced those out so evenly. I would recommend you use a pencil if you're doing this your first time. And so I'm going to try to make, even though they have different numbers, I'm going to try to make their graphs or their dot plots the exact same. So 20 and 60, they have 25, 30, 35, 40, 45, 50, 55, 25, 30, 35, 40, 45, 50, 55, 60. So now I'm just going to go ahead and start constructing my dot plots. So let's start with the 11. So I have a 27 that's somewhere in here. I have another 27, another 27, another 27. So I should have 4 dots on 27. 2, 3, and 4. Then let's see, I also have 1, 2 28s, so that's pretty close. 1, 2 28s, and then 1 29 right next to it, and then a 31 next to that. So that's the shape of our Levum data, and that's a type of tomato plant. Let's move on to the wonderful data. We have a 20, just one of them. We have a 22 that's right next to it. We have a 22 25, so I could put 2 of those right there. We have a 31, a 32, and then we have a 50 and a 51. 50, 51. Okay, so now I've got my dot plots constructed. Let's go ahead and keep going. Now I can find the mean, and I can find the MAD. So let's start with the mean of this one. The mean of this one. We'll find those means, we'll mark them on our dot plots. So let's go ahead and do that. So remember, in order to find the mean, all we got to do is add all those values up. Let's see if I can do this here. I have 27 plus 29 plus 27 plus 28 plus 31 plus 27 plus 28 plus 27. So I get a total of 224, which then there are 8 values of. So if I divide that, I get 28 as my mean, which seems reasonable because it should go about right there. If my mean measures my center, that's pretty close to the center of my data. Let's find the mean of our other one. Hopefully I can see through my scribbles here. I have 31 plus 20 plus 25 plus 50 plus 32 plus 25 again plus 32 plus 51 at the top end. So this time we have quite a bit more, 266 divided by 8 again. And so our mean for this one would be 33.25. 33.25. Okay, so let's find that on here. Going to be about right there, which looks like, given that that data is kind of spread out, that looks like a pretty good measure of center. So we've got our mean, or we've got our MAD. Now, it's time to figure out what our MAD, well, we've got our means, we don't have our MADs. So let's go ahead and find our MADs. So again, how do I do that? I'm going to find the differences of all these values compared to the mean. So this might take some really intense calculations. What I'm going to do is I'm going to keep track of my calculations right here. And to do that, I'm just going to find, let me explain, I'm getting my values first, and then I'll kind of skip through it after a while. So remember, I'm taking the mean, and I'm subtracting each individual value. So like I'll start with 28 minus 27. So my first value I'll be thinking about is obviously 1. Then my next value is 29 for this one, minus 28. That would be 1, and then I can just keep going. I have 1 again, 1 again. So 1, 2, I have only 1 so far. Then I have 31 for my fifth value. So I'm thinking 31 take away 28. So that gives me 3. And then I have 27 again, so that's a 1 for my sixth one. I have 28 for my next one, so that's 0 followed by 1. So I find the sum of these, and I find the mean absolute deviation. 1, 2, 3, 4, 5, 6. Add 3 is 9. So the mean absolute deviation here is 9 divided by 8, which is going to be 1.125 if you type it in on your calculator. So this is our MAD for this particular one. This is our MAD. Let's go ahead and figure this out for wonderful. This one's going to be a little more complex. First of all, let's go ahead and take our mean. Let's make this easier on ourselves. Let's round it. So let's use 33 as our mean. So if I do that, my first one would end up being 33 take away 31. So my first value is, or my first deviation is 2, followed by 33 minus 20. It's going to be 13. Then 25, that would be 8. And then 50, that would be 17. And then 32, that's only going to be 1. 25 again, and we've already done 25, and we did 25 as 8, so it's 8 again. And then we have 22, and that's going to be 11. And then our last one's 51. And again, how am I getting that? I'm taking 51 minus 33. And so this one, it was 17 before with 50, so this one must be 18. Now I just got to add all those up, and hopefully I can get an answer. I'm going to add them in chunks to make it faster. Here, this is 15. This is 9. These two would be 9 and 2, so 29. And then 8 and 17, that would be 25. So now I can add those together a little quicker. Oh, actually, no, this one too. This would be 38. And then here I can add these two together. 5 and 5 is 10. So I have, this one should end up being 40. Oh, I guess I didn't need the calculator after all. 0 and 8 was 8, and that was maybe famous last words, I guess. 4 and 3 is 7. And so our MAD is going to be 78 divided by a total of 8 values. So I'm guessing this one's going to be about 9.25 would be my guess. Let's check and make sure. 78 divided by 8, 9.75, my fault. 9.75 is the mean absolute deviation here. So let's think about what this means for our writing. When I'm writing about this problem, I need to consider, and you may need to use a different sheet of paper as I'm going to, we got to write about each of those things we've found. We've found the mean. We've found the mean. And so let's think about what this states about the tomato plants. I'm going to zoom out a little bit here. I'll write kind of big so you can see what I'm writing. And again, you may need to be finding a different sheet of paper to do this. So first, it wants to know, remember, which tomato plant they should use. Well, let's take a look here. Imagine you're the one who has to buy these tomato plants. Typically, this one produces more on average. It says it typically produces 33 tomatoes, compared to this one, which produces 28. The problem is, look, these are all guaranteed to be around 28. It's very likely they're around 28. We know that because the mean absolute deviation is so small. But here, they're very spread out. So if you grow this plant, yes, you very well could get 33, but that's not really a typical value. Because look, it could be anywhere from 20 all the way up to 52, 51 or 50. So we're not really, this one's not as certain. So here, based on the evidence I would go with, I would choose love them. So that's going to be our assertion we have at the end. So at the end, we're going to want to say something like, therefore, we should choose the love them plant. So let's start with some of the facts we know. Let's see how we can start. Let's start with our mean. So normally, the wonderful plant produces 33 tomatoes, which is 5 more than the normal amount the Lovum produces. So there's one of our first facts. Normally, the wonderful plant produces 33 tomatoes, which is 5 more than the normal amount the Lovum produces. So then we could say something like, let's talk about the mad. However, 33 is not a good measure of what's normal because the data is so spread out. So there's another fact. So then I can keep building off of this, right? In fact, the mad of the wonderful is, and let's see how different they are. Remember, this one's almost 10, and this one's about equal to 1. So it's almost 9 deviations more. That means it's super spread out. So in fact, the mean absolute deviation of the wonderful is 9 more deviations than the Lovum. So there's another fact. We've got 3 quality facts stated. We've got tons of work shown so far. So let's go ahead and write our assertion. So therefore, the best plant is the Lovum because it's more predictable even though you get fewer tomatoes. So finally, we have our assertion with our word therefore. So that's a pretty long response, and we produced that after quite a bit of work. So this is a giant problem, but it's also a pretty awesome problem to think that you can produce all of that on your own.